Mixing line voltage and low voltage wiring in the same conduit is a safety hazard primarily due to the difference in insulation ratings. Line voltage conductors are typically rated for 600 volts. Low voltage conductors are typically rated for 50 volts or less. This difference in voltage rating is crucial for safety and proper function. If you were to run both types of wires within the same conduit, you introduce the risk of insulation breakdown in the low voltage conductors. This breakdown can occur due to various factors, including heat generated by the line voltage wires, physical contact between the wires, or even the presence of moisture within the conduit. When the insulation fails, it can lead to a short circuit, which is a dangerous situation that can result in fire, equipment damage, and electric shock. The National Electrical Code, or NEC, provides guidelines for safe wiring practices, and it specifically prohibits running line voltage and low voltage conductors together in the same raceway, cable, or enclosure. The NEC aims to minimize the risk of electrical hazards and ensure the safety of people and property. The best and safest way to run line voltage and low voltage conductors is to use separate conduits. This physical separation ensures that there is no direct contact between the two types of wiring, reducing the risk of insulation breakdown and short circuits. By using separate conduits, you maintain the integrity of each circuit and minimize the potential for interference or accidental contact. When you use separate conduits, the line voltage wiring is contained within its own protective pathway, and the low voltage wiring is also contained within its own pathway. This segregation makes sure that any fault or issue in one circuit does not directly affect the other circuit. For instance, if there were a short circuit in the line voltage wiring, the separate conduit would help prevent the fault from propagating to the low voltage wiring, protecting the low voltage equipment and preventing further damage. There are several benefits to using separate conduits. Firstly, it enhances safety by reducing the risk of electrical hazards such as short circuits and fires. Secondly, it simplifies troubleshooting and maintenance as each circuit is isolated and easier to identify. Thirdly, it complies with electrical codes and regulations, ensuring that the installation meets safety standards. When running separate conduits, it's essential to size the conduits appropriately to accommodate the number and size of conductors. The NEC provides tables and guidelines for determining the correct conduit size based on the wire fill. Overfilling a conduit can lead to overheating and insulation damage, so it's crucial to follow the NEC recommendations. In addition to using separate conduits, consider using shielded cables for low voltage wiring, especially if it runs near sources of electrical noise or interference. Shielded cables provide an extra layer of protection against electromagnetic interference, or EMI, which can affect the performance of sensitive low voltage equipment. When locating the transformer on the basement joist, you will need to run a separate conduit from the transformer to the ground fault circuit interrupters, or GFCIs, and low voltage lights. This separate conduit is essential for maintaining electrical safety and complying with electrical codes. Firstly, the line voltage conductors from the main electrical panel will need to be run to the transformer location. The size of the conduit and conductors will depend on the transformer's input voltage and current requirements, as well as the distance from the panel. Consult the NEC tables to determine the appropriate size for the conductors and conduit. Secondly, from the transformer, separate conduits should be run to the GFCIs and the low voltage lights. The conduit for the GFCIs will carry line voltage conductors, while the conduit for the low voltage lights will carry low voltage conductors. Again, the size of the conduits and conductors will depend on the load requirements and the distance from the transformer. It's essential to use the correct type of conduit for the application. Electrical metallic tubing, or IMT, is a common choice for indoor wiring, while rigid metal conduit, or RMC, or PVC conduit may be used for outdoor or underground applications. Ensure that the conduit is properly supported and secured according to the NEC guidelines. When wiring the GFCIs and low voltage lights, follow a specific sequence of steps to ensure safety and proper operation. Firstly, turn off the power to the circuit at the main electrical panel. This will prevent electrical shock during the wiring process. Secondly, identify the line voltage conductors, neutral conductor, and ground conductor in the conduit running to the GFCIs. Use a voltage tester to confirm that the power is off before proceeding. Thirdly, connect the line voltage conductors to the line side terminals of the GFCI receptacles. The line side terminals are typically marked with the word line. Fourthly, connect the neutral conductor to the neutral terminal of the GFCI receptacle. The neutral terminal is typically marked with a white wire or the letter N. Fifthly, connect the ground conductor to the ground terminal of the GFCI receptacle. The ground terminal is typically marked with a green wire or a ground symbol. Sixthly, repeat steps 3 through 5 for each GFCI receptacle in the circuit. Make sure that all connections are tight and secure. Seventhly, run a separate conduit from the transformer to the low voltage lights. Identify the low voltage conductors in the conduit. Eighthly, connect the low voltage conductors to the appropriate terminals in the low voltage lights. The terminals may be marked with polarity symbols such as plus and. Ninthly, ensure that all connections are tight and secure. Tenthly, turn the power back on at the main electrical panel and test the GFCIs to ensure that they are working properly. Press the test button on each GFCI receptacle and the receptacle should trip. Reset the receptacle by pressing the reset button. The GFCIs are designed to protect against ground faults, which can cause electrical shock. They should be tested regularly to ensure that they are functioning correctly. When installing low voltage lighting, consider using LED fixtures, as they are energy efficient and have a long lifespan. LED fixtures also produce less heat than traditional incandescent or halogen fixtures, which can reduce the risk of fire. Another important consideration is to use weatherproof enclosures and fittings for outdoor wiring. This will protect the wiring from moisture, corrosion, and other environmental factors. Weatherproof enclosures and fittings are designed to withstand harsh weather conditions and maintain the integrity of the electrical connections. When running conduit outdoors, it's essential to bury it to the proper depth. The NEC specifies minimum burial depths for different types of conduit and wiring. Burying the conduit helps to protect it from physical damage and prevents it from becoming a tripping hazard. In addition to following the NEC guidelines, it's also important to consult local electrical codes and regulations. Local codes may have additional requirements or restrictions that must be followed. It's always best to check with the local electrical inspector to ensure that the installation meets all applicable codes and regulations. The location of the transformer should also be carefully considered. The transformer should be mounted in a dry, well-ventilated location where it is not exposed to moisture or extreme temperatures. It should also be mounted securely to prevent it from falling or being damaged. When mounting the transformer and the basement joist, use appropriate mounting hardware and ensure that the joist can support the weight of the transformer. If the joist is not strong enough, reinforce it with additional supports. The transformer should also be accessible for maintenance and inspection. Leave enough clearance around the transformer to allow for easy access. Regularly inspect the transformer for any signs of damage or overheating. If you notice any problems, such as unusual noises, smells, or discoloration, have the transformer inspected by a qualified electrician. Transformers can generate heat during operation, so it's important to provide adequate ventilation. Ensure that there is sufficient airflow around the transformer to dissipate the heat. Do not cover the transformer with insulation or other materials that could trap heat. When working with electrical wiring, always follow safe work practices. Wear appropriate personal protective equipment, or PPE, such as safety glasses and gloves. Use insulated tools and equipment. Never work on live circuits. Always turn off the power before working on any electrical wiring. If you are not comfortable working with electrical wiring, hire a qualified electrician to do the work. Electrical work can be dangerous, and it's important to have it done correctly to prevent accidents and injuries. Firstly, ensure proper grounding. Grounding is a critical safety measure in electrical systems. It provides a path for fault current to flow back to the source, tripping the circuit breaker or fuse and preventing electrical shock. All electrical equipment, including the transformer, GFCIs, and low voltage lights must be properly grounded according to the NEC guidelines. Secondly, use appropriate wire connectors. Wire connectors are used to join two or more wires together. There are various types of wire connectors available, such as wire nuts, crimp connectors, and push-in connectors. It's important to use the correct type of wire connector for the application and to ensure that the connections are tight and secure. Thirdly, protect wiring from physical damage. Wiring should be protected from physical damage by running it in conduit or using cable trays. If wiring is exposed, it should be protected by guards or barriers. Damage to wiring can lead to short circuits, electrical shock, and fires.